So to talk about phase diagrams, the first thing we need to discuss are what are phases. So a phase of matter is a volume of space with uniform properties. And properties, that is really determined by the nature of the materials we're looking at. For example, if we're looking at liquids, perhaps we're looking at then the densities, or if we're looking at solids, perhaps we're looking at crystalline versus amorphous, or maybe different crystal structures. But regardless, we have to have some way to make a distinction. In material science, most of the time we're looking at solids. The solids have different crystalline behavior. So for example, we'll have two different phases that are mixed together in a solid. And because they have either different compositions or different crystalline behavior, we also wind up with different optical properties. So the most common way to look at microstructures is to look at them through an optical microscope. And in that, we will observe differences in the phases based on their reflectivity. So you have basically have a microscope in which you're shining a light from above, and then you're looking at the reflection of light off that surface. And the different crystal structures, different compositions will have a different reflection. So you'll wind up with some say picture here, and you'll have some set of and this is a terrible microstructure, but some microstructure, and you'll wind up with some dark phase, and then some light phase. And the phases, they don't actually have colors because, for example, they're from some metal or from some ceramic, but we're actually looking at the difference in the reflectance from the surface. Talking about phases, we can also think of different phases in a kind of a macroscopic picture, liquid and solid, for example. And some of our examples we're going to talk about early are going to be about the difference between liquid and solid, and talk about melting and vapor phase as well. Some of the phases are actually, or phase distinctions are actually fairly fine. For example, in some of the perovskite compounds, for example, a barium titanate, which is a very common dielectric material. In barium titanate, it's BaTiO3. You have barium atoms on the corners of a cube, and you have titanium in the very center of the cube, and then on each of the faces, you have oxygen. Well, this is cubic, and it can go through a polymorphic phase transition. Basically, it's changing morphology, changing the lattice, but keeping the atoms in the same position. Like this. So now, instead of being A by A by A, we still have the same basic structure. But now it is A by C. You have a tetragonal structure. And when you have this type of transition, you have to use other means to measure them. They aren't necessarily going to show up differently in the microscope, and in fact, they oftentimes don't coexist. So what you're going to have to do is use some type of method to measure the ordering of atoms, for example, a diffraction or a measurement of the electrical properties.